In part 2, we're going to explore how to turn a program written in a high-level language into something the computer can understand. Let's start by introducing our toy programming language. This looks pretty similar to how C++ or Python handles the addition of two numbers. Just like in C++ or Python, our toy language assigns the result of 5 plus 3 to a variable and then returns back. But what happens behind to turn this into something a computer can run? Before we dive into the world of compilation, let's imagine we're reading a recipe to bake a cake. What is the first step? We need to understand all the individual ingredients, equipment like a mixer. And this is exactly the first step of compilation. The compiler breaks down the program into basic building blocks, or tokens. These tokens are like the ingredients of the program. By splitting the code into tokens, we give the computer smaller, digestible pieces to work with. This first step is usually referred to as lexing or tokenization. Let's go back to our recipe for cake example. Once you've gathered all the ingredients, what's the next step? It's not enough to just have the ingredients. You need to know the order of the steps to make the cake. You have to combine, mix, and then bake. But never combine, then bake, then mix. The order matters. This is exactly what happens in the second step of compilation. It takes the tokens, or ingredients, from lexing and makes sure they are used in the right order. For example, the line result equal 5 plus 3 might be organized like this. This structure tells the computer that we want to add 5 and 3 together first, and then store the result in the variable result. We call this structure an abstract syntax tree, and we call this entire step parsing. If lexing is like identifying the ingredients, then parsing is like following the recipe, making sure everything is done in the correct order. Without parsing, the tokens would just be a random list of ingredients with no clear instructions on how to combine them. Parsing ensures we follow the steps in the right order, like mixing the batter before putting it in the oven. In short, parsing makes sure the computer knows exactly what steps to follow to execute the program correctly. Once the structure is in place, the final step is called backend code generation. In this step, we take the organized structure from the parser, the AST, and transform it into assembly language, the language the computer can actually understand and execute. You can see why the AST structure is so important here. Each branch and node in the AST maps directly to specific machine operations. Every assembly instruction corresponds to a part of the structure we created during parsing. This is why we call this step code generation, or simply code gen. It takes the logical structure of the program and converts it into a series of instructions that the computer will follow.